Hi there! For the next type of factoring, we're going to learn about common monomials. Common monomials, simply we're going to get the common factors for variables and constants of a certain expression. Let's have some examples. Say we have 10m squared n, okay, plus say 15 m cubed n squared, and lastly minus, let's say 25 m to the fourth n. So how are we going to factor this? Okay, I'm going to write the answer here because this is not enough anymore. So let's do it. Okay, so the first thing that we're going to do, let's first consider the constant. In this expression we have positive 10, positive 15, and negative 25. All you have to do is to find the GCF for each number, for each constant. Okay, meaning what is the greatest number that you can divide from these three numbers? And that is nothing but 5. So put 5 here for the first term. Okay, and then, well, you may not write the parentheses anymore. So just imagine you're going to put the 5 here also. Meaning you have to divide each term by 5. After we finish with the constants, let's go to the variables. Let's investigate. What are the common variables for the three terms? Obviously, we have m and n. So let's consider first m. If we write m here, we need to consider the exponent. For the first term, you have the exponent is 2, the second term is 3, and the third one, we have the exponent for m as 4. Okay, so what are we going to use as a factor or common monomial for variable m? Okay, here's the key. You have to choose the variable with the least, okay, with the least exponent. For this example, the smallest exponent for the variable m is nothing but 2. So you consider m squared. And you're going to write here m squared for each term. There you have it. And obviously we have n for each term. So we have to consider n as a factor also, a common factor for the three terms. Again, we're going to choose the least exponent for the entire expression. Here we have the exponent is 1, here we have 2, we have 5 here, and then we choose 1 or simply n. And then we're going to write here n. Okay? Remember that what we're doing here is nothing but, a scratch. Okay, you're not going to write this here when you're really answering problems like this. And then this is now the same as this. And then we're going to put the next factor. Now, what are we going to write here? Okay, the next factor, this is the first factor, this is the second factor. You're going to answer each term. Okay, so let's start with the constant 10 divided by 5. Yeah, very clear. 10 divided by 5 gives us 2. And now for the variable m squared divided by m squared will give you 1. You're not going to write the 1 here anymore. Okay, because 1 times any number will give us the same number. Here also we have to cancel the 2 n's. So the only quotient for this is 2. Okay, so we have answered this term. Okay, we proceed with the next term. We have to copy this sign here. Okay, this time we start again with the constant. 15 divided by 5 will give us 3. Alright, now this time, how are we going to solve for m? So m cubed divided by m squared. Let's have a scratch here. M cubed divided by m squared. Okay, how are we going to answer this? So you simply have to subtract 3, okay, by 2, or simply 3 minus 2, okay, and the answer is 1. So this means we have a quotient of m. We don't have to write the 1 here anymore. So you write here the m. Alright, just the same as this one, n squared all over n, right here, and the answer to this is nothing but n. So you write here n. Alright? So for the last term, you copy this sign, negative, and then once again, we consider first the constant. So let's divide 25 divided by 5 will give us 5. And again, just like what we did here, you're going to subtract 4 by 2. That gives us m squared. And 5 minus 1, there's a hidden exponent 1 here. 5 minus 1 will give us 4. And then close parentheses. And this is now our answer. However, if you wish to check whether your answer is correct or not before your teacher does, okay, this is how we're going to check. You need to apply the principle of distributive property. Meaning to say, you have to distribute this by multiplying 5m squared n by 2 and should give us the product like the first term. So let's check. 5 times 2 will give us 10, and then just copy this. M squared times n will give us a term like this. So our first term here is correct. What about the second one? Okay, so 5m squared n multiplied by 3mn. Let's start with the constant. 5 times 3 will give us 15. We're correct. And then look at this. M squared times m will give us m cubed. Meaning you have to add the exponent. 2 plus 1 will give us 3. Alright, let me repeat. M squared times m will give us m cubed, just like this, because we add the exponent. We have 2 plus 1 here will give us 3. And lastly, n times n will give us n squared, just like this. Alright, and we do the same thing for the last term. Distribute again, so that means 5m squared n multiplied by negative 5m squared n to the 4th. Let's start with the constant. So 5 times negative 5 will give us 5 times negative 5 will give us negative 25. And m squared times m squared will give us m to the 4th. We add the exponents, right? And finally, we have n times n to the 4th. Since we have a hidden exponent of 1, so 1 plus 4 will give us 5. And there you see, this distributive property will give us the original problem, which is 10m squared n plus 15m cubed n squared minus 25m to the 4th and to the 5th. Okay? And this is our first example. And that is how you will check your answers. Okay? Let's have a shorter one. For the next example, say we have 16x y, okay, minus, let's say, 8x squared y cubed, and then again minus, let's say, 24x cubed y squared. Okay? So, I'm going to write the answer here. Alright? Okay, we will just do the same method as we did in the first problem. So let's concentrate on the constants first. We have constants like 16, negative 8, and negative 24. These are constants in this trinomial. So what do you think is the number that can be divided for the three constants 16, negative 8, and negative 24? Okay, that's correct. The number is 8. Okay, so we put the denominator for the three terms 8. And now we're finished with the constants. Let's go to the variables. Okay, the variables. Now, obviously, all of them contains x and y. We put here x and y for all of them. Oh, I forgot this one. Yeah. And all the terms here will have to be divided by 8xy. Now, the next factor here, we're going to put a parenthesis, is nothing but the quotient for each term. Okay, let's start with the first term. We divide first the constant. 16 divided by 8 will give us 2. Okay, now, since we have xy here and xy here, that means when you divide them, alright, we have a quotient equal to 1. We're not going to include the 1 here because 1 times 2 will be 2. Okay, for the next term, you have to copy the sign. Okay, now we have here for constant, you have 8 divided by 8 is 1. You don't have to write the 1 anymore. Okay, for the variables, for x variable first, x squared divided by x, meaning you have to subtract 2 minus 1 here will give you 1, or simply x. Alright? So it's just like this. X squared all over x will give you x. So 2 minus 1, we have a hidden exponent 1 here. 2 minus 1 will give you 1. You don't have to write the 1 here. And it's here. Okay? For variable y, we have y cubed divided by y, meaning 3 minus 1 will give you y squared. That's the exponent. We simply subtract the exponent when we are dividing the variables. Okay? Now, for the last term, again, you copy this sign. So 24, or simply negative 24 divided by positive 8 will give you negative 3. Okay? For simplicity, sometimes we just copy the sign here. So we have 3. For constant, okay, so x cubed divided by x will have x squared y, simply because 3 minus 1 will give us 2 here. For the last factor, we have y squared all over y. Simply 2 minus 1 will give us 1, or simply y. Okay, and then put the close parentheses. And this is now your answer. Again, to check whether your answer is correct, you simply do the same thing here. You apply the principle of distributive property. Now, when you do that, your answer for that distributive property will be the original problem that we have before. Okay? So let's try. 8xy times 2. We have 8 times 2 will give you 16, and then copy this xy, we have this. Alright, for the second term, we have 8xy times negative xy squared. Okay, since we don't have a constant here, you simply write the 8 here, and then look at this. X times x will give you x squared, we add the exponent, and y times y squared, we add the exponent, that gives us y cubed. Okay? And the last one, we have to multiply 8xy by negative 3x squared y. How do we do that? We first multiply the constant. 8 times negative 3 will give us negative 24. And when we're finished with the constant, let's follow the variable. X times x squared, we add the exponent. 1 plus 2 will give us 3, so x cubed. And finally, we have y times y will give us 1 plus 1 here, the exponent will be 2. In other words, when you multiply this using the principle of distributive property, your answer should be exactly equal to the given problem. Okay? So that's how you solve factoring using common monomials. I hope these two examples here will give you an idea, and somehow you will learn how to do factoring using common monomials in a simpler way. Thank you very much for watching my video. Hope to see you soon in my next videos. Thank you so much.